Right. So we're going to do just some more problems. We're just going to make sure that we can do the problems for today. And then as you can see, there's an activity set up around the room for us. Because who wants to do a worksheet every day? I sure don't. We're gonna get up and walk around the room today. All right. So example, we did 3 examples in the notes. Is that right? 3? Okay. This is example 4. Example 4. Is there a movie playing? Yeah, do you hear like dramatic music playing? That's not just in my head. So we have k squared minus 2k minus 3 over k squared minus 4k minus 5 times k squared plus 8k plus 7 over k squared plus 4k minus 21. And we should just start off by going, all the k squareds are gone, right? K squareds cancel, k squareds cancel. Oh, dead puppies if we do that. Let's not kill the puppies. Kill puppies. Oh, no. Oh. Whew, don't kill the puppies. Joke's on you guys because I did marker. Alright, so we're not killing puppies. That would be terrible. Let's not kill the puppies. What should we do instead? Factor. So this is like I was saying yesterday, is that if you do not factor a lot today, you are doing something wrong. Like I should be able to say, like if you're like, Ms. Rice, I have a question, and I'm like, have you factored yet? And you say no. I'm like, factor first. I should be able to immediately say like factor something. Just factor something and you're on the right track. All right, so we have lots of just regular factoring here. Like lots and lots and lots of it. So we're looking for what multiplies to -3 and adds to -2. We're also looking for what multiplies to -5 and adds to -4. We're also looking for what multiplies to 7 and adds to 8. We're also looking for what multiplies to -21 and adds to +4. Lots and lots of factoring. Multiplies to 7, adds to 8. That's this one. It's not a decimal. 7 and 1. Okay, so we did that one. Anybody have any of the other ones?
Yeah, I have -3 and 1, and then I have -5 and 1.
Okay.
I have
that is not an answer. Is not an answer. So we're going to need some numbers. 7 and -3 is a great answer. Okay. So if we write those factors down, so for the top left one, we have k minus 3, k plus 1. On the bottom, we have k minus 5, k plus 1. The top right, we have k plus 7, k plus 1. The bottom right, we have k plus 7, k minus 3. Okay. So we are just looking for factors on the top and the bottom that could cancel out to become a 1. So the same factor on the top, the same factor on the bottom, those cancel to make 1. So what factors do you see? Okay, so k minus 3 and k minus 3, those make a 1. That divides to be 1. Okay. K plus 1, those divide to be 1. But only one of them, so we can only cancel these two. We can't cancel this one over here. That one has to stay behind. the k plus 7s. Okay? So we got those divide to be 1, these divide to be 1, these divide to be 1. That's it. That's all that divides to be 1. So the rest of it is our leftovers. So our answer is k plus 1 over k minus 5. Can we cancel the k's and get like negative 1/5 or something like that? No, we'd kill puppies if we did that. We don't want to kill puppies today. It's too nice outside to be killing puppies. No, no. You do have the hair that would go along with somebody who likes killing puppies, though. Yeah, we're getting some puppy killer vibes over there. All right. Are Cheerios the breakfast for puppy killers? Okay, 42k squared minus 48k over 18k squared minus 30k divided by 28k squared minus 32k over, sorry, let me show you. There we go. 12k squared minus 20k. Some students hate this type of factoring. What type of factoring is this? Greatest common factor. The type of problem that it is a keep, change, flip problem. But the type of factoring that it is greatest common factor. So example 5, it's a division problem. Now, when I do my division problems, I do not like to factor first thing. The very first thing I like to do is what? I like to keep, change, flip. So keep the first fraction the same, change this to a multiplication sign, and then flip the second fraction. So keep it, change it, flip it. That's what I like to do, is just kind of get the problem started that way, and then I can do all my factoring and canceling. The reason I don't factor to start with is because a lot of students, as soon as they start factoring, they start canceling things out. And so you don't want to do that prematurely and then accidentally cancel things that aren't allowed to cancel. Okay, so keep, change, flip. That blue is just like real aesthetically pleasing. I don't know about you guys, but I'm a fan. Nobody? Nope. Okay, that's cool. All right. Between the 42 and the 48, what number is in common? 6. 6 and a k. And then once we take out the 6 and the k, what's left?
7k plus
8. Okay. Between 18 and 30, what's in common? 6k. Ooh, again. And when you take the 6k out, what's left over? 3k minus 5. Okay. Between 12 and 20, what's in common? Is it 4? 12 and 20? Did I say 10 and 20? Between 12 and 20, we said 4. 4k is in common, and then what's left over? Ooh, that's tricky. Between 28 and 32, what's in common? Ooh, that's crazy. And what's left over? Ooh, look at that. Nobody? Crazy. Crazy. Whoa. Whoa. What's about to happen? Disappearing stuff. All right. Tell me what stuff is going to disappear. Everything. So we're going to get 0 as the answer, or... Okay, so what disappears? Okay, so 4k and 4k divides to be 1. Okay, what else disappears? 6k, I said that weird. Divides to be 1. Okay, what else? 3k minus 5 and 3k minus 5 divides to be 1. 7k minus 8 and 7k minus 8 divides to be 1. So if everything divides to be 1, then what's your end result? 1. So all of that just equals 1. When my child is 1 year old, I'm going to teach them to say, I am squared minus 48k over 18k squared minus 30k times 12k squared minus 20k over 28k squared minus 32k. So I'm going to teach. That's what I'm going to teach my child to say when they turn 1. Why? They're going to say it's my 42k squared minus 48k over 18k squared minus 30k times 12k squared minus 20k over 28k squared minus 32k birthday. That's what they're going to say. That's what it's going to be. It's going to have a candle that says 42k squared minus 48k over 18. No? Okay. I was committed. I was going to read it again if you guys needed me to. Yeah. All right. Okay, I want to show you guys another type of problem that I didn't used to do these types of problems until I found it on the EOC, and I was like, you sneaky buggers. That's how I felt when I saw it on the EOC. You sneaky little buggers. So but I threw away my example problems last year when I was teaching the year-long math reclass because I thought I was only going to teach year-long. And then we got Miss Adams on staff, and then she started teaching year-long, and then all my example problems were gone. So I'm going to come up with this one on the spot. Are you guys ready? It's going to be good times. Okay. We're going to do x squared minus 4 to the negative 1. X squared plus 3x plus 2 to the negative 1. Did you just whisper, heck yeah? Oh, you said okay. Okay. That's cool. This is really hurting my brain to do this right now. And then we're going to have... Nope, we're good. We're going to keep going. And then we're going to have another fraction over here. This one is going to have x squared minus 1 to the negative 2. Ooh, this is real good. Oh, this is too much for my brain. It's too much. And then this one's going to be... I'm panicking. My brain is panicking! Make it stop. No, because then you guys will already... Is it like a problem? Am I fake using a problem? And then... X squared plus x minus 2. Yeah, okay, to the negative 1. Okay, that was way too hard. That's too much for my brain altogether. Okay. Does anyone remember what negative exponents do? Anyone remember? You remember your properties of exponents at all? No? Marvelous. Okay. What your negative exponents do, all they do is they take whatever this is and they move it to the opposite side of the fraction. So the first thing you're going to do when you see something like this is you're going to take whatever this is and you're going to move it to the other side. So x squared minus 4 to the negative 1, to make that a positive exponent, you're going to take it and you're going to move it to the other side of the fraction. So x squared minus 4 to the negative 1, we're going to move it to the top. X squared minus 4, now it's a positive 1. Because I moved it from the bottom, where it was a negative exponent, I moved it to the top. That's how you make your exponents positive. So the x squared plus 3x plus 2 that had a negative exponent when it was on the top of the fraction, for us to fix it, we should just move it to the bottom of the fraction. We just have to move it to the other side. So this one, we're going to take the x squared plus 3x plus 2, we're just going to move it to the bottom. Just switch it, just swap it. Yep, just swap it. So it started off as a multiplication problem. It's still a multiplication problem. It's just that where the parts appeared in the fraction is actually not where they were. We thought they were on top, but they were actually on bottom. We thought they were on bottom, but they were actually on top. And that's because they had those negative exponents. We're going to move that to the top. So we're going to say x squared minus 1 to the positive 2. And then x squared plus x minus 2 to the positive 1. We don't even have to write that exponent. Okay, so from here, we can go through and we can factor everything that we had to factor. So on the top, we had x squared minus 4. What type of factoring is that? Difference of squares. So what would that be? X plus 2, x minus 2. Good. Okay, so I'm going to go ahead and write that one out. X plus 2, x minus 2. Okay. On the bottom, we're looking for two things that multiply to 2, but add to 3. 2 and 1, okay. So x plus 2, x plus 1, okay. Now, the top on the right, this one is a little bit tricky because it's difference of squares, right? X squared minus 1 is difference of squares. So what would x squared minus 1 be? X plus 1, x minus 1, but it says that it's that squared. So how many times should we write that set of parentheses? Twice, yeah. So we're going to do x plus 1, x minus 1. X plus 1, x minus 1. There's the first set. And because it's squared, we have to do that twice. So x plus 1, x minus 1, and then x plus 1, x minus 1. So we did it, but we had to do it twice because it was squared. Are we good with that? X plus 1, x minus 1, x plus 1, x minus 1. We had to do it twice because it said squared. Are we comfortable? Everybody good? Okay. Then on the bottom it says what multiplies to negative 2 but adds to 1. What multiplies to negative 2 but adds to 1. 2 and negative 1. All right, so what do I put on the bottom? X plus 2, x minus 1. All right. Let's see what we can cancel out here. What do you guys see? All right, I got an x plus 2 and an x plus 2. Those divide to make a 1. What else? Okay, an x plus 1 and an x plus 1. Okay. Okay, and x minus 1 and x minus 1. Okay? Anything else? Yeah, those aren't the same. Okay, so at this point, that is our answer. Now we just got to write it. Okay, now you do not have to multiply out the stuff that you have for your answer. We've got 3 sets of parentheses on top, and we can leave them in parentheses. There is no need to FOIL that stuff out. So I'm going to write the top out as x minus 2, x plus 1, x minus 1. And then the bottom was x plus 2. And I'm going to leave that as my answer. All right. Good? Makes sense? Okay, I have one last example for you, and then we will do the around the room activity. And you have video notes tonight on regular notebook paper. All right, the last example is very short, so if you're running out of paper and you want to do it in like the margin or something, you could probably fit it. Okay, so last example is a division problem. Here's example 7. We're going to do 2x to the third over 5 divided by 4x squared over 25. All right, it's a division problem. So what should we do? Keep it, change it, flip it. Keep it, change it, flip it. It does sound like a bop it. I mean, it's about as fun as any game you could ever play, so. 2x to the third over 5 times 25 over 4x squared. Okay. So here's what I do, is I look for things that are kind of like in common, like the 5 and the 25. You guys see that? 5 and 25. 5 goes into 5 one time, right? 5 goes into 5 one time. 5 goes into 25 how many times? 5 times, okay. What else is similar that I could also reduce? The 2 and the 4, the x squared and the x cubed, okay. What do we see about the 2 and the 4? Okay, 2 goes into 2 one time. 2 goes into 4 twice. Okay. What do I see about the x squared and the x to the third? Yeah. So the way that I think of it when I have the x's is I think of it as x squared would be 2 x's written next to each other. X to the third would be 3 of them written next to each other. And if we have 2 of them and 3 of them, how many are going to cross out? 2 on the top and 2 on the bottom, so 4 total. Yeah, so when I think of it this way, I like to think of it as expanding them. So x squared would be xx, x to the third would be 3 of them. And then I just cancel 1 with 1. So I would cancel 1 here, 1 here, 1 here, 1 here. I do straight canceling. Does that make sense? So I think of it as like, oh, there were 2 on the bottom, there were 3 on the top. The top wins, it has an extra one. Does that make sense? And so I'd say the extra one on the top is the only one that's left over. That's kind of how I think of it. So I'd say, okay, 2 on the bottom, cancel with 2 on the top. The top has 1 extra one left over. All right? That's how I think of it with my variables. I think of, does the top win? Does the bottom win? How much does it win by? It won by 1. It WON by ONE. Gotta love the English language. Okay, so on the top, we have 1x to the first power times 5. On the bottom, we have 1 times 2. So when we multiply straight across, what do we get? We get 5x over 2. Now, you could have multiplied the blue stuff without simplifying. You could have done 2x to the third times 25 over 5 times 4x squared and gotten a more complicated answer and then reduced. So you would have gotten 50x to the third over 20x squared, and you could have reduced it from there. It's just a little bit easier to reduce your numbers first and then multiply because you're dealing with smaller numbers. Does that make sense? That's a math trick, to reduce first and then multiply, as opposed to multiplying and then reducing. If you multiply first, you deal with bigger numbers before you reduce. If you reduce first, then you're dealing with smaller numbers. Does that make sense? It's a little math trick to make your life easier. All right? Okay, any questions about multiplying, dividing? How are your brains? Brains are good? Yes, Miss Rice, our brains are, okay, marvelous. All right, so for today's activity, you're going to get out a blank sheet of paper. Go ahead and do that now. Blank sheet of paper. The only reason for a calculator is for little, like, multiplication, addition, here and there. If you struggle sometimes with the multiplication facts, you might need one. Just adding or subtracting. So calculator is beneficial but not necessary for today. You might want one for your comfort, but you don't necessarily need one. I would probably have one if I was you. That's just me. So you're going to start anywhere in the room. It doesn't matter where you start. Pick a problem. Write down the letter of the problem that you were starting with. You're going to do the problem. You are not going in alphabetical order, so you're going to do the problem. You're going to either multiply it or divide it. You're going to simplify the answer. From there, you look for that answer on another card. That tells you what problem to do next. So this is a similar style. We've done this type of scavenger hunt before. Making sure you're checking your answers as you go. Any questions about how the activity works? Okay, make sure you ask me if you struggle. Sound good?